Okay, so today we're going to talk about how to use percent composition to figure out the empirical formula. Okay, so it's short for EP. Okay, EF, empirical formula. Okay, short for the empirical formula. Let's use one example, okay, to figure out. Okay. So I think we have examples here. Okay, we have one of the example here. Okay, let's look at the example number 2. Example number 2 here. Okay, this one is called an oxide of the chromium is found to have the following percent composition, which is the chromium is 68.4% chromium and 31.6% oxygen. So now determine empirical formula for this compound. Okay, so chromium 68.4, oxygen 31.6, 68.4, 31.6, 68.4. Okay. Okay, let's come here. Okay, so we need to figure out there's two chromium 68.4%, and the oxygen here is 31.6%. Okay, this is the percent composition in this chromium oxide. Okay, this chromium oxide, but we don't know what is the ratio between the chromium and oxide. This is what we need. What we need is we try to figure out the ratio between the chromium and the oxygen. Okay, once we know the ratio here, we will figure out what kind of chromium oxide it is. Okay, so you're gonna know what is Y and X here. Okay, so this is what we need. We need to find the ratios here. Okay, so there's a steps to do so. Okay, there's a path to doing this kind of experiment. Okay, and this kind of so first, okay, let's see. We begin with the so here we're gonna chromium percent and oxygen percent. Okay, so this is a percentage, but generally you can convert this the percentage to the mass. Okay, you can convert this to the mass, which is just time 100. Okay, just time 100. So 68.4%, you can just assume first you make this to the mass of a chromium. Okay, and this one you do so the same thing. You figure out the oxygen mass or the mass of oxygen. Okay, you first figure out the mass of oxygen and mass of the chromium. Then what are you going to do? You're going to, okay, so you need to convert the mass to the mole. Okay, so now the next part is you figure out the mole of the chromium. Okay, and you also figure out the mole of oxygen. Okay, because the ratio here Actually, those are mole. So you have you can convert to the mole of the chromium, convert to the mole of the ratio, or mole of the oxygen. Okay, then the next step is divide each compound. Okay, what happened? Divide each element by the smallest mole number. Mole number. Okay, divided by smallest mole number. If you don't know what is that, we will figure out later. Okay, I first gave you the pass. Okay, what are we gonna do with it? Okay, so now we have chromium. We're gonna mass. We're gonna mole, and then we divide it by the smallest mole number. Then, based on this, you can figure out the ratio between chromium and the oxygen. Okay, based on here, you will figure out what is the ratio between chromium and oxygen. Okay, and then the next step is going to round up. Okay, after the rounding, you will find the empirical formula. Okay, so actually it's not hard. Okay, after rounding, you will find the empirical formula. Okay, so let's do the example, just like a chromium oxide. Okay, so you will do the same thing for the rest of the other. Okay, for the other calculation to fit, if you want to figure out the empirical formula, you do the same pass. Okay, so the chromium here percent, we got 68.4%. Oxygen, we have 31.6%. Okay, first step, we change to the mass. Okay, so the mass, we got 68.4 gram of the chromium and 31.6 gram of the oxygen. Okay, the next step, you're going to figure out the mole. Okay, then you need to figure out what is the mole of the chromium. Okay, what is the mole of the chromium? The mole of the chromium you got, which is just use the 68.4 gram divided by the molar mass. The molar mass of chromium is 51.996. I just use 52. Okay, so divided by 52 gram per mole. Okay. So let's use the calculator to figure out what is the mole of this 68.4 divided by 52, and I got 1.3154 mole. Okay, once again, please don't round up at now. Okay, we're going to round at the very end, but now please don't round. Okay, and the next part we'll need to figure out what is the mole of the oxygen. Okay, this is 31.6 gram divided by 16 gram per mole. The 16 gram per mole, that's the molar mass of oxygen. Okay, now we got 31.6 divided by 16, which is 1.975 mole. Okay, so once we got the mole, what's the next step? We already got here mole of the chromium and got mole of the oxygen. The next step is develop each element by the smallest mole number. Okay, what that mean? Smallest number. So we have 2 moles. Okay, the mole chromium is 1.3154. Mole of oxygen 1.975. Which one is the smallest? Chromium has the smallest mole number. Okay, so for the 2 of this, we're going to divide by the chromium smallest mole number, which is 1.3154. Okay, so now we got chromium divided by oxygen. Okay, so now chromium divided by oxygen, that's gonna be the chromium, we need to divide by everything divided by chromium. Okay, everything divided by chromium. So chromium divided by chromium, that's gonna be 1.3154 divided by 1.3154. Okay, here this is a mole and this is a mole. So that's gonna be 1. Okay, the next part, oxygen also need to divide by the chromium. Okay, so what we have here is 1.975 mole divided by 1.3154 mole. Okay, then you can get a number. Let's see. 1.975 divided by 1.3154. Okay, what I have is 1.5. Okay, this is 1.5 ratio. Okay, so now we already divided by the point. So in this case, what we can have? We can find the ratio between the chromium and oxygen. Okay, the ratio between chromium and oxygen is 1 versus 1.5. Okay, it's 1 versus 1.5. Okay, so what that mean? That means, okay, generally I can figure out the formula, the empirical formula for the chromium oxide is going to be chromium 1 times oxygen 1.5. Okay, yeah, but the thing is we're not finished that yet. Okay, last time we talked about we're going to round. Okay, we're going to round these ratios, but just to let you know, if the ratio has a 1.5 or 2.5 or 1.25, please don't cut the tail. Okay, please don't cut the tail, because those numbers may, if you multiply 2 or multiply 4, it will make a whole number. So please don't cut those numbers. Okay, if the ratio is a 1.1 if the ratio is a 1 versus 1.99, then go ahead, round up to 1 versus 2. Okay, if the ratio is a 1 versus 1.05, go ahead, cut the 0.5 to make a 1 versus 1. Okay, but if this number have a 1.5, if 1 versus 1.5, then please don't cut the tail. You're going to keep is 1 versus 1.5 because it will change to 2 versus 3. Okay, if you multiply 2, you will change this to 2 versus 3. Okay, so if the number is a 1 versus 1.25, okay, it could be 1 versus 1.25. Please cut the tail. Please don't cut the tail. Okay, please don't cut the tail, because 1 versus 1.25, if you times 4, you will got 4 versus 5. Okay, So 0.25 and 0.5, this is specific. Okay, please don't round it up. Please don't round it up. Okay, or cut. Please don't round or cut. Okay, so now what we have is here, chromium has 1 chromium and 1.5 of the oxygen. Okay, then for the empirical formula, you're going to have those number as a whole number, not a fraction or the decimal. Okay, so we time 2 on the both sides, on time 2 on both elements. So the empirical formula is going to be chromium 2 and oxygen 3. Okay, so this is the empirical formula. Okay, this is the empirical formula we can have. Okay, this is the empirical formula we can have. Okay, so if you're not familiar, we'll go ahead. Let's do one more. Let's do one more practice. Okay, let's do one more practice. So how about let's do number 4, okay? Number 4, this one, number 4 here is not talking about the percentage, but generally it's the same, okay? This is a mass. So if we only know the percentage of the element, we convert the percentage to the mass first, right? So here we have mass, so we can directly to calculate from mass to the mole, right? So here we have a lead is a 38.43. Okay. Okay, so next part. So we have a lead 38.43 gram. Carbon is a 14.83. Oh no, 17.83 gram. And hydrogen is 3.74 gram. Just double check. Okay. 3.74 gram. Okay, so still we do the same thing. Okay, first we figure out we have the mass, then we convert the mass to the mole. Okay, so let's figure out the mole of the lead. Okay, that's gonna be 38.43 gram divided by the molar mass of the lead. Okay, the molar mass of the lead here is 207 gram. Okay, it's 207 gram per mole. Okay, so 38.43 divided by 207, that's gonna be 0.1857, okay, mole. The carbon, so the mole of the carbon, 17.83 gram divided by the 12 gram per mole. Okay, so 17.83 divided by 12 is 1.4858 mole. Okay, the next part is hydrogen. The mole of the hydrogen you got 3.74 gram divided by 1 gram per mole. That's still 3.74 gram. or 3.57 mole, 704, 3.74 mole here. Okay, so now we already have the gram more, we have everything. Okay, then what do we need to do? Okay, we find the ratios. Okay, go ahead, we find, okay, smallest number. Okay, so lead here has the smallest mole number. Then everything gonna divided by the smallest mole number. Okay, so the lead, okay, lead is a PB. So let's just write PB, not the lead. So PB divided by PB, that's definitely is 1. Okay, then here carbon divided by PB, 1.4858 mole divided by 0.1857 mole, and that one is 1.4858 divided by 0.1857. They give us number is 8. Okay. Okay, the next part, hydrogen divided by the lead. Okay, so hydrogen divided by lead is a 3.74 mole divided by 0.1857 mole. Okay, 3.74 divided by 0.1857. So what I have is a 20. Okay, what I have is 20. Okay, so now I figure out the ratio between the lead and carbon and hydrogen here is a 1 versus 8 versus 20. Okay, so now we will know the compound, the empirical formula for here is lead, 1 lead, 8 carbon, and 20 hydrogens. Okay, so usually for the formula, we don't write 1 here. So you can just write this one is going to be lead, carbon 8, and hydrogen 20. Okay, then this is the formula. Okay, this is the empirical formula. Okay, this is the empirical formula. Okay, so why don't you do the one of the practice here? Let's see. So why don't you do number 5? Okay, make a practice for number 5. The percent composition of a compound was found to be 63.5% silver, 8.2% nitrogen, and 28.3% oxygen, and determine the compound's empirical formula. Okay. So anyone already figured out? Who need 1 more minute to work on this? Okay. Okay, so let's do some the practice on this one. Okay, so here we know we have silver, which is 63.5%. Okay, so what is the percentage for nitrogen? And what is the percentage for the oxygen? Sorry, would you mind to type on the chat? Okay, let me go back. So the percentage for the silver 8.2 and 28.3. 8.2, 28.3%. Okay. Once again, so now we have the percentage. Then you're convert that to the mass, right? So the mole of the silver is going to be the mass of the silver, which is 63.5 gram divided by the molar mass of the silver. The molar mass of silver is equal to 107 107.87. 107.87. 107.87 gram per mole. Okay. And for the mole of the nitrogen, that's going to be 8.2 gram divided by 14 gram per mole. And the mole of the oxygen, that's going to be 28.3 gram divided by 16 gram per mole. Okay. Okay. Then you put everything in your calculator. 63.5 divided by 107.87. That's 0.5887 gram. Oh, mole. Nitrogen is gonna be 8.2 divided by 14. 5857 mole. Okay, oxygen 28.3 divided by 16. 1.76 88 mole. Okay, now you see which one is the smallest. So nitrogen here is the smallest. So everything divided by the nitrogen. So Ag divided by nitrogen is almost equal to 1, right? 0.8557 divided by 0.5857. So we can just assume this is close to 1. And this one is nitrogen divided by nitrogen definitely is equal to 1. And this one is oxygen divided by nitrogen. Then you have 1.7688 divided by 0.5857. What I got, I think is should be 3. Okay, so now for the combination, okay, silver, nitrogen, and oxygen. So here is a silver 1, 1, 3 here. Okay, so but usually we don't write 1, so you can just write silver, nitrogen, and 3, all 3. So this is a silver nitrate. Okay, so this is the empirical formula for the silver nitrate. You got it? Okay, so let's have a break. Okay, and we will talk more. Okay, everyone, please come back. Okay, I think one more thing I need to mention for the empirical formula, which is, okay, in the lab, in the percent composition lab, okay. Uh, oh, I think, by the way, I need to mention here, okay. So if we talk about composition, percent composition, for example, if I want you to figure out what the percent composition for the copper sulfate, then generally you're gonna figure out what is the percentage for the copper, and what is the percentage for the sulfur, and what is the percentage for the oxygen. Okay, so this is talking about the percent composition. Okay, and based on the empirical formula and also the equation I gave to you, it just use the molar mass of the copper divided by overall the molar mass of copper sulfate. And here the molar mass of sulfur divided by overall copper sulfate. And molar mass of the oxygen divided by overall copper sulfate molar mass. Okay, so this is how you figure out the composition. Okay, percent composition for each of the elements in the formula. But in the lab, in the lab actually it's asking. So I just give your example. Okay, so if we know so in your experiment, generally you can know the mass for the hydrate. Well, to not confuse you, okay, probably just you use this. Okay, this is the Epsom salt. Okay, this is the Epsom salt. This is the Epsom salt. Okay, so based on your experiment, generally you can figure out what is the anhydrate and the Epsom salt. This is Epsom salt without the water, right? So you should figure out what is the mass of the magnesium sulfate, and also you should figure out the mass of the water. So based on this, you generally can figure out what is the empirical formula for this hydrate. Okay, generally you just need to figure out what is X. Okay, that's the same thing, just like what we figure out the empirical formula. If you already figure out the mass of this, you already have the mass of this. You're doing so same thing. You're going to figure out the mole of the magnesium sulfate. Okay, and also you're going to figure out the mole of the water. Okay, so based on this, then you're divided by the smallest mole number. Okay, divided by the smallest mole number. Okay, here, and then you should find the ratio between the magnesium sulfate versus the water. Okay, so this one should be 1 versus X. Okay, now you will figure out what is the X here. Okay, of course this is based on your experiment data. This is based on your experiment data. It's not based on the empirical formula. Okay, sorry, it's not based on the formula. It's those data is from your experiment. Okay, the mass of the magnesium sulfate and the mass of the water is from your experiment, and then you figure out the mole of this and the mole of this. You divide by the smallest whole number, you can figure out the ratio between the magnesium sulfate and the water, which is 1 over X. Okay, and so X is what you need, and this is the X. Generally, you want to figure out how many water molecules is in your hydrate. is in the Epsom salt. But just to let you know, since this is your experiment, so this x may not be equal to 7, okay? So the real thing is we should have a 7, but the x could not be 7, okay? So just based on what I want to see is based on your calculation, what is x it could be, okay? Based on your calculation, what the x is could be. So please don't give me, if your calculation is not 7, please don't give me a 7, okay? I just want to see what your calculation it could be based on your experiment, okay? Yeah. So this is part for the lab, okay? This is for the lab. Okay. So now we already have the empirical formula. Then how can we use the empirical formula to figure out the molecular formula? Okay, so how can we use the empirical formula to get molecular formula? Okay, remind ourselves. Okay, so how did we get? What's the relationship between the empirical formula and the molecular formula? Okay, so remember, I think this is the ethene. This is ethene, and this is the molecular formula. Okay, so next time I'm just write MF. So this is molecular formula. We try to figure out this empirical formula. Generally, we try to get the smallest whole number, right? Smallest whole number ratio. Okay, so empirical formula is just a CH3. So this is the empirical formula for this compound, ethene compound. Okay, so you see what's the difference between this? The difference is the empirical formula is gonna time a ratio, then you will figure out what is the molecular formula, right? So empirical formula, as long as it time a ratio, you will figure out the molecular formula. So this is the ratio is the key. The ratio is the key. As long as we can find the ratio, we can find the molecular formula. Okay, so that is the key. Then how do we find the molecular formula? Okay, let's just work on one of the example. Okay. Okay, so let's see, number 11. Number 11, okay. So you see, it says empirical formula of the hydrocarbon. Hydrocarbon is found is CH. That's the empirical formula. The laboratory procedure have found the molar mass of the compound. The molar mass of the compound is not, this compound is not the molecular formula, okay? This compound is just talking about the molecular formula, it's not the empirical formula. This compound, the molar mass of compound is 78 grams per mole. And then what is the molecular formula of this compound? Okay, so we know the empirical formula here is CH. So based on this, you can figure out what is the molar mass, right? The molar mass of the carbon and hydrogen here is a 12 plus 1, which is 13, okay, gram per mole. So the molar mass is a carbon 13 gram per mole. That is the empirical formula, okay? We already figured out the molecular formula. The molar mass is 78 gram per mole. Okay, so that is the difference. The difference actually is the ratio. So the ratio, what we want is just the molecular formula, the molar mass of the molecular formula divided by the molar mass of the empirical formula. Okay, so what I have is 6. So the ratio is 6. So the empirical formula is a CH, then the molecular formula is going to be C6H6. And this one is the benzene. Okay, so this is how we figure out, based on the empirical formula, we figure out the molecular formula. The key is we try to figure out the ratio. The key is try to figure out the ratios. Okay, generally for the to figure out the molecular formula, the question usually should give you the molecular the molar mass of the molecular formula. If the question don't give you the molar mass of the molecular formula, then you can't figure out. Okay, you can't figure out the molecular formula. Okay, so and some of the question actually they combine those two things together, which means the first step you first see like a 12 question 12. Question 12 is telling this nicotine, the molar mass of nicotine is a 16, it's a 162.1 gram per mole. Okay, and also it tell you it has the carbon, hydrogen, and the nitrogen, and also tell you the percentage of there. So based on this, this question, you can first based on the percent, the mass percent or the percent composition to figure out the empirical formula. And then you're based on the empirical formula and the molar mass of the whole compound, you can figure out what is the molecular formula. Okay, so sometimes they combine those two questions together. Okay. Answer 11 is this, benzene. Because the ratio, you see, 78 gram per mole divided by 13 gram per mole, the ratio is 6. Okay, so empirical formula times the ratio is the molecular formula. Okay, so that's going to be C6H6. Okay, okay. Okay, so I think I will do last practice for the number 12, then we're done for the empirical formula and the molecular formula. Okay, so first this one, we found the mass of the carbon, the mass of the hydrogen, and the mass of the nitrogen here. This is nitrogen, okay? Mass of the nitrogen here, okay? So the mass of the carbon is 74.0 gram. Hydrogen is 8.70 gram. Nitrogen is 17.3 gram, okay? And then you convert to the mole. It's mole carbon, 74.0 gram divided by 12 gram per mole. And here, this is a mole of the hydrogen, 8.7 gram divided by 1 gram per mole. And this is nitrogen. That's going to be 17.3 gram divided by 14 gram per mole. Okay, then put this into the calculator. 74 divided by 12. That's a 6.1667 mole. And this 8.70 mole. And this is 17.3 divided by 14. That's 1.2357 mole. Okay, and then this is the smallest number, so everything divided by nitrogen. So carbon divided by nitrogen, 6.1667 divided by 1.2357. 1.2357. That's equal to 5. Okay, so carbon, no, not carbon, hydrogen divided by nitrogen. 8.70 divided by 1.2357. 8.7 divided by 1.2357. What I have is 7. Okay, and this nitrogen divided by nitrogen, that's going to be 1. So now your God's empirical formula is going to be so carbon, hydrogen, and nitrogen. Okay, what I put here is 5, 7, and 1. Okay, so now you have C5H7N. Okay, so this is the empirical formula for the nicotine. Okay, and then based on this, you can figure out what is the molar mass for this empirical formula. Okay, the molar mass of this empirical formula, that's gonna be 12 times 5 plus 7 times 1 plus 14. Okay, so that's gonna be 12 times 5 plus 7 plus 14. So 81. This one is 81 gram per mole. Okay, so empirical formula is 81 gram per mole. And we know the molecular formula, the question is already gave, is 162.1 gram per mole. Okay, so the ratio is molar mass divided by molecular formula divided by empirical formula. So 162.1 divided by 81. So I got 2 here. Okay, so that means empirical formula as the empirical formula times 2, that's going to be a molecular formula. So the molecular formula here is going to be C10, 714, and 2. Okay, and so this is the molecular formula for the nicotine. Right? So it's not that hard. As long as you can follow the steps, you will figure out the empirical formula and the molecular formula. Okay? Empirical formula and the molecular formula. It will. Okay, so any questions so far? No question? Okay. Let me see. Okay, so this is the molecular formula. Okay, this is the molecular formula.